Welcome again to the Modern High School e-learning program 2020. Of course, I'm Mr. Ganga, going to take through JSS2 chemistry. And basically, on this side of the page, you can see detail of the topics that are expected to cover in this particular lesson. So to take you through, we're going to have to look at metals, non-metals, and metalloids. We have to look at their physical and chemical properties in brief. We'll also look at the physical properties and chemical properties of non-metals as well. We'll look at metalloids generally. We'll also have a look at alloys and their properties. And of course, we'll look at also some examples of alloys and their uses. So to take you to the next page, like I told you, elements generally in the periodic table are divided into three categories. And that includes metals, non-metals, and of course, metalloids. And to talk about metals, these are elements that usually lose electrons. Of course, they are valence electrons. That means electrons that are found on the outer shell to form cations. So basically, we are saying that metals are specialized in the formation of positive ions or cations, all right? Whilst they go through chemical reactions. Because basically, elements take part in chemical reactions because they want to gain some form of stability. The other thing that I want to talk about is that they include elements such as those in groups 1, 2, 3, and the transition metals. Of course, transition metals are not part of our periodic table for the first 20 elements. They normally start from elements number 21 right through to 30 and above. But basically, I can just give you some examples here like iron, zinc, nickel, manganese, copper, as their symbols there are there to actually take it through. And lastly, we also have metals make up the largest group of elements in the periodic table. That's a fact. All right? When you take a look at the whole or the total number of all the elements in the periodic table, you realize that metals make up the largest group of elements. Like I told you, we have three categories of elements. However, amongst those three, metals are the ones making the largest group. All right? There's a table here that's actually going to take us through the physical and chemical properties of metals. Now, let's look at the physical properties of metals. Metals generally are solids at room temperature except mercury, which is actually a liquid. Of course, that is a fact, and it should be noted. Number two, metals are shiny and lustrous. Of course, most of the metals we see around, including iron and so on and so forth, most of them have a shiny surface. All right? Number three, metals are malleable. That simply means that they can be beaten into what? Sheets. All right? Of course, we do have our, gates, doors, or windows that are actually made of iron metal. We have to look at how they are actually able to spread out those metals like that in order to be able to convert them into those shapes. So that's basically what we are talking about. It must have that property of malleability in order for it to be able to be beaten into shape. Number four, we'll look at metals are ductile. That simply means that they can be drawn into wires. Even when we talk about our electricity in Sierra Leone, we have the current being taken from Bumbuna to Freetown, which is where most of us in Freetown do get our electricity from. The current actually travels through metal wires, and those metals sometimes can be made of either copper or aluminum. So you can see the distance being covered by that particular, or those metals. So how those metals were actually being able to draw, to be converted into that length is actually what we are talking about. So that property also is a very important property for metals. Number five, metals have high boiling and melting points. That's also another important point. Number six, metals are good conductors of heat and electricity. Of course, that's a very good point to note. If you want to prove that, you only need to take a piece of metal. Please don't try this one, GSS2. Don't try this one because it can be very dangerous. If you slot any piece of metal into your electricity socket, of course, you know what that means you can be shocked, and that can lead to death. So don't try it at all. But I'm just saying that metals are good conductors. Or sometimes you want to also try that. Maybe you can use a metal. Just try to place one end of your metal, holding on the other end, and place it into fire, and see after some moment you see exactly how that metal is going to react to that particular heat. Right? So basically those are the physical properties of metals. And then we'll now begin to look at the chemical properties. We'll look at them in brief, just simple ones. Under chemical properties of metals, one of them is that metals react with oxygen to form basic oxides. Generally, we have what we call bases and acids, but I'm not going to look at that in detail anyway. I can only tell you that when metals react with oxygen, they are able to form metallic oxides, which are actually basic. That means they have a basic property, all right? So the equation below there is giving us a clear example as to how sodium, as an example of a metal, which is group 1 element or group 1 metal, is actually reacting with oxygen to form sodium oxide. Of course, you can see the formula. They are very, very important. That equation is very important. Take note of that. Number 2, metals displace hydrogen to form acids. What we are actually saying here is that they can react with hydrogen also to form acids. They can react with acids to form what? Salts and hydrogen gas. All right? That's also a very important point. That means zinc, as an example of a metal reacting with hydrochloric acid, is going to form zinc chloride and hydrogen gas. So you can see clearly how that property also is being manifested there in that equation. Number 3, metals react with water to produce their respective hydroxides. That means sodium, taking it as an example, will react with water to form sodium hydroxide. Magnesium will react with water to form magnesium hydroxide. Iron will react with water to form iron hydroxide, and so on and so forth. So that is the reason why we are saying their respective hydroxides. All right? So that is the number 4. Metals have high tendency to lose electrons to form positive ions. Remember, I told you that. That is also important. In fact, that's one of the first things we spoke about. That means metals generally lose electrons to form cations, which are normally positive ions. So we're done with that. We'll go to the next page and then begin to look at non-metals. For non-metals, they are normally elements that gain electron or electrons, as you can see in bracket. That means some can gain 1 electron or some 2 or more. That's the reason why you have the S placed in the bracket. To form anions, which are negatively charged ions while they undergo chemical reactions. The second point we're going to discuss about non-metals is that non-metals we normally get them from groups such as group 5, group 6, and group 7. All right? Elements in group 8 are neither metals nor non-metals because they neither lose or gain electrons, which indicates that they already have a field electronic configuration. So they actually don't need to react at all. They don't react at all at any cost. All right? So that's it. So now let's take a look at the physical properties of non-metals as opposed to those of metals. One of the physical properties of metals is that their gases are liquids at room temperature, except carbon or iodine, which are solids. So in any case, carbon, of course, is one of those elements that exist naturally as a solid, which is a non-metal. Of course, diamond is the purest form of carbon, and graphite, which are actually solid materials. But iodine as well can serve as an example of a non-metal, existing as a solid. Number 2, solid non-metals are hard and brittle. That means that they are actually solid, and when non-metals exist in solid form, they have that ability to easily get broken. All right? They are hard, but then can be easily broken. That's what exactly that simply means. Number 3, non-metals are bad conductors or poor conductors, we can put it that way, of heat and electricity, except for graphite, which is actually an example of carbon. All right? So that is it. They are poor conductors of heat and electricity, like I told you. Metals are very good conductors. So you can see that there is a direct opposite of those two characters there, of the two types or groups of elements. Number 4, nonmetals are neither ductile nor malleable. That means they can neither be beaten into sheet or what? Drawn into wires. So they are that of. Number 5, they have low boiling and melting points. All right? When you take a look at metals, we said they have high. So you can see that most of the properties of metals and non-metals are like contradictory. This is the opposite of the other. All right? Number 6, metals are poor conductors of heat and electricity. Of course, we also discussed that. We said metals are good conductors. Here, non-metals are poor conductors of heat and electricity. So you also have to pay attention to that. Number 7, they are dull and not shiny. We also said that metals are shiny. Here we are saying they are dull. So non-metals are dull, if at all they are present or they are available in their solid state. Now let's take a look at the chemical properties of metals. Non-metals. One of the chemical properties of non-metals is that they react with oxygen to form acidic oxides called acid anhydrides. Except for what? Water. Of course, hydrogen has a large proportion of a non-metallic property. So when it combines with oxygen, it's going to form a particular oxide which is actually neutral. So it's not having any form of acidic property as in the case of the other non-metals. Like we are having examples there. Carbon reacts with oxygen to form carbon dioxide, and sulfur reacts with oxygen also to form sulfur dioxide. And those two both have very acidic properties, and that is the reason why each and every one of them, if reacting with water, have the tendency to form acid rain. All right? Number 2, they have high tendency to gain electrons to form anions during chemical reactions. That means non-metals also have the ability to gain electrons during chemical reactions to form anions. All right? Number 3, non-metals usually form stable hydrides. That means when non-metals react with hydrogen, they are able to form stable compounds. All right? So an example there is carbon reacting with hydrogen to form what we call methane. All right? That gas there is called methane. Going further, all right? Okay, for today's lesson, I think that's all we have. And that's why we're going to stop for today and hope to see you again next week. But mind you, don't forget, your questions following this particular lesson should be clearly answered, and hope to see you again next week. Thank you, Mr. Ganga. Thank you very much.